So hi, I'm Michael Price. The talk here is on function default arguments, slingshot or shotgun. Currently I'm an employee at Synopsys working on a static analysis engine where I do a lot of compiler front-end work. And some work that we had recently done sort of required a more stringent look at default arguments and sort of inspired some of this talk. So hopefully I'll get to mention that later on in the slides, but we'll see. So who all here thinks they know what function default arguments or default function arguments are? Just raise your hand. Everybody thinks they know. Okay. So how many people here think that you know most everything that there is to know about them? Okay, we got a couple. Okay, yeah. Okay. Well, let's get started. So the basics. So a function default argument are expressions that are evaluated when there are fewer provided arguments to a function call than the number of parameters specified in the function definition. Okay, so with all that words, you have a declaration or definition of a function, right? And it's got 4 parameters, right? You have a call site for that function that it only provides 3 arguments, right? Normally, this would be a compilation error, right? You didn't provide enough arguments to satisfy the signature for this function. But if the definition or declaration of the function has specified default arguments, then you can leave off arguments at the end of your call, right? And it's pretty common. Most languages these days have some form of this, and it looks like a pretty basic and simple language feature, right? What can go wrong? So some terminology. So function default argument, or is it default function argument? So when I first came up with the title, I thought about this and I settled on function default argument. As I was actually writing, preparing all the material, I decided, default function argument actually makes more sense. So, the term default argument appears in the working paper for the standard a lot, right? So there's a whole section, sort of dedicated to default arguments that's listed there. And in some places in the standard, they actually use the term default template argument. They don't really use the term default function argument, though. So default template arguments are a lot like default function arguments. It's just they're provided for template parameters, type and non-type parameters, right? You can say type name, t equals int, right? To say that if you don't provide this type parameter, we're just going to assume it's an integer. And so you kind of have to, when you're looking at the standard, you kind of have to put it, when you receive default argument, you have to put it in the context of what they're talking about to sort of understand what it is. So I'm going to call them default function arguments, or just DFAs, from here on out through the rest of the presentation. So a simple example. I'll let you grok this for a second. Okay, so, it's pretty simple. We have a function called fn that takes a string and returns a string. It just returns the string you gave it. And we provided a default function argument of the string foo, right? So then in our main function here, we can assert that if you pass in a string to fn, you just get that string back. If you don't pass any string in, you should get the default back, which is foo, right? Simple, easy, piece of cake. Now, this is sort of like the first sort of entry level, this is obvious, right? This shouldn't confuse anybody. Now, you can have a default function argument in lots of different cases, though. You can put them on member functions. You can put them on parameters in the lambda, the signature for a lambda, right? You can put them in there. You can put them in function templates, so on and so on. Most of the time, if you're doing something simple, the syntax that you think should work is what's going to work. Okay, but there are some restrictions. So default function arguments cannot do all of these things. So you can't put them in function like operator functions, like operator plus. You can't put a default parameter on the type or on the parameter or default argument on the parameter there. unless it's operator call, parens, right? Because that makes sense. You know, it's a parens, you're calling it. So you can't collide with things. You know, they can't appear in friend declarations except with some exceptions. You know, there's an interesting thing that got added. So concepts is being added in, right, to the language, or trying to get it added into the language. And they introduced a thing called requires expressions, which can actually sort of introduce a signature just for type checking. You can't put them there because it doesn't make any sense, because you're never going to invoke that thing. It's just for doing the type checking. It can't show up in defaulted member functions, user-defined literals. There are other things like it can't be provided for the size t parameter of, if you have a custom new function, you can't say, oh, no, if you don't say what size, I'm going to say, 10, right? They won't let you do that. There are other things that make sense, right? It can't be for parameter pack because that's the other feature that lets you sort of throw extra things in, right? And one that kind of gets some people is that you can't use it to deduce a template type of parameter, right? So in function templates, you can say, template type name t, void fn t I equal 1, right? If you call the fn with no parameters, it won't let you do that because it can't figure out what the t is, even though you have a default argument, right? It's just like, no, I'm not going to let you do that. Okay. So there are even more restrictions. So that was things that default arguments can't do themselves, right? These are restrictions on what you can put in a default argument. Because remember, default arguments are expressions, right? Just about any expression you can come up with in the language that you could form can be used as a default argument, except for these cases, right? So you can have a lambda as the default argument, but only if it doesn't capture anything. You can actually have the capture specifier, but as long as it doesn't capture anything, then you're good. If it captures something, the compiler will complain. Can't put the this keyword in. There are various reasons for that. And that last bullet point, previously declared parameter names unless in an unevaluated context. So if in my signature, if I said int a, comma, int b equal a, right? To be just like, yeah, just give me whatever the first parameter is. I want that same thing if you didn't give it to me explicitly. That's not allowed, right? Even if there's another a somewhere in scope that's visible globally, it will find the a in the signature, but it will not let you do that. In order to get the one that's out of scope, you have to put the scope operator and give it a more qualified name. Okay. Just as an aside, there will be time for questions later, so I know that's a lot of stuff to process. Who here likes lots of pictures in their presentations? Okay, sorry, I'm not going to have any of those. Who here likes code examples in the presentations? Good, I've got lots of those. Okay, who here likes live demos during their presentation? Okay, if we go fast, I might be able to do that. So, okay. Before we get into more examples, so the whole premise of the talk is slingshot or shotgun, right? So who's familiar with foot gun? Like C++ is a foot gun. It's like putting a gun at your foot and waiting for it to go off. So that inspired that subtitle of this, right? So, a shotgun, it spreads, it can be really damaging and harmful, right? You don't want to shoot your foot with a shotgun. A slingshot, a slingshot can hurt, right? It can be very dangerous. But usually it's a little more finer, precision, right? It's not a shotgun. So we got to decide, what is it? I'm going to say it's mostly a shotgun. If you use it carefully, it can be a slingshot. But okay. So advice: don't use them. Okay, unless it's that simple case that we saw right there. Just don't. If you're tempted, don't do it. Okay. There's a caveat. There are some really cool uses for default function arguments. Yeah, maybe you could use those. Probably not. But if we get to it, I'd like to show some of those. But again, we got to go fast. So. All right, so if I said don't use these things, the first thing you're going to say is, but I want to, I want to, right? What can I do instead? So there's an alternative. So in C++, we have function overloading, right? An overloaded function can take, multiple sets of parameters, right? And you can use this delegation method, right? So on lines 1 and 2, we have, sort of the default arguments version, right? If you provide no parameters or no arguments to that, you're going to get back the string foobar, right? Then we have a one that uses overloading and delegation, right? So, if you don't provide anything, we're going to call the one argument form with foo, okay? And then that's going to sort of insert the second default bar and then delegate up to the one that takes both parameters, right? That's it's a lot more typing. It's a little safer for various reasons. You can see the assertions here that I've made. They're equivalent right there, right? Regardless of which technique you pick, they're the same. But it turns out that that's not exactly true. They are not perfectly equivalent things. For one, you've got multiple functions, which means multiple symbols in your symbol table, right? Whereas with the default argument form, there's only one symbol, right? That could affect things like if you're in an extern C block, which says no, you can't do overloading there, right? So if you're in that, you can't do this. You have to, and you want this, you have to use the defaults. So here's a more devious example of why they're not equivalent, though. So if you look at lines 6 through 13, those are basically the same as the previous slide that we saw with code, except that the default arguments aren't literals now. It's a call to a function called next, okay? And if you look up at line 4, the next function is basically indexing into some global array, right? And then it's actually keeping track of where you're at. It's like an iterator, right? Okay, so what's so bad about this? So on line 17, you can see we called defaults with no parameters, and we get bar foo. If you remember previously, in the previous example, we got the first argument and the second argument, right? And you would think that we're going to index into this array. So why aren't we getting foobar? Does anyone want to offer a suggestion?
The order of declaration in the function call is unspecified.
Right. So the next these expressions that are the next function call. Whenever you make that function call, it doesn't. There's the order in which those functions are called are unspecified. So in this particular case, the second default argument gets called first, and it gets the value foo, and then the first argument gets called, invoked, and it gets bar. Or sorry, it gets foo. No, it gets bar. So you get bar foo. It's like, okay, that's unfortunate. But if you see the delegation method, because we've now sort of are delegating the evaluation of those expressions in a more ordered way, we get kind of what you would expect, right? Foo bar. But it turns out you can still call delegate with those expressions, directly. And when you do that, you still get the old, the unevaluated order problem, right? You get bar foo, right? So this is why, like when I say use delegation and overloading instead, if you try this, if you have default arguments in your code and you try to go replace them, you got to be careful. You may have some problems. This is where testing will come in very handy, right? Everybody has tests in their code, right? Who doesn't have tests? I'm going to shame you. Okay, good. Nobody gets shamed today then. Okay, there's another problem. So say you're going to go do this. Well, how would you go about doing it? You would start replacing these things, right? Well, while you're in that intermediate state where you have some that are default arguments and some that are overloads, you can create situations where it's ambiguous then, right? So here we have two functions are overloaded, the overload set of fn. One takes a string and an int, and one takes a string and a bool. Okay? The second parameters in each of them have defaults. Right? So in our main function on line 13, I can call it normally with 2 arguments. On 14, I can call it normally with 2 arguments and get what I expect. But if I try to call it with 1 argument, now it has to decide which one of these is the right one. Well, since both of them could be called with a single argument, now we have an ambiguity problem. Luckily, this will just fail to compile instead of like picking one at random or something, right? So that make it harder to transition if you're trying to get rid of these and go towards delegation. It's just something you'd have to deal with. Okay, so that was all the basics. Everybody feel like they have a good idea, a good understanding of the basics of how this works? Great. So names in a default argument are bound at declaration but evaluated at use. Okay, should be a code example. Okay, line 1, we have a global B, foo. We have a namespace n on line 3. We say string function with a parameter string s equal b, and we're just going to return s. Then the next line inside the same namespace, we have another string called b, that's bar. Now, down in our main function, when I call the namespace n function with no parameters, it's going to go, okay, I need to get the default argument, right? I need to fill that in. It's going to pick the one on line 1, not the one on line 5, right? Because whenever you scan the line 4 and find that default argument of b, he's going to go, okay, well, let's find a b. Do I know a b? He will not have seen the b that's on line 5 yet. So he's going to bind that name to the global b, right? But he's not going to evaluate it yet. So then whenever you actually call it and it's required, he goes, ah, okay, the default argument. Okay, I got it. That's that global b you told me about earlier. And so he's going to use that. So you get foo. Now, if you just say b right there too, you'll get foo, right? Because it's going to find the global one. But you could provide explicitly the namespace n one and get bar. So here's a little bit of a trick though. Like I said, it's bound at time when it sees it, a declaration, but it's not evaluated until you use it. So now on line 13, I changed the value of the global b to foo_bar_baz. Now when I call the function with no parameters, no arguments, it's going to get the global b, which is now foo_bar_baz. Okay? So you have to be careful about what it's picking, right? You could get unexpected results. Or you could get expected results if you know what it's doing. Okay, so that's one step of complication. It gets more complex. So default function arguments can be provided across multiple declarations of the same function. So how do you know if you have 2 declarations of a function, how can you tell that they're declaring the same thing? There are rules that state what is equivalent, like how functions are equivalent, right? And the default arguments do not play into the rules about whether something is equivalent or not, right? It's all about the signature. It's not, in other words, the default arguments are not a part of the signature of the function. Okay, so line 1, we have a function that returns auto, which is going to be a string, and takes a string and takes a bool. We provide a default argument for the second parameter, b. It's going to be true. We can have another declaration after that that now provides a new default argument for the first parameter, leaving off the default argument for the second parameter. This is line 6. Okay? A lot of people, when they see line 6, they're going to go, that won't compile. No, that can't be right. Because we know that you have to provide default arguments for everything to the right of you, right? Like if you're going to say one for parameter 1, parameter 2 has to have a default. And clearly on line 6, there's no default there. But they're additive, right? So the set of default arguments is a union of the default arguments provided in all those declarations. So now on line 10, when I call my function with no parameters, I'm going to get foo for the string and true for b. So I'm going to get foo back out of it. Okay? And it's just like if I had declared it all in a single declaration, right? So please no one ever do this. If someone's looking at code, like doing a review or something has gone wrong, that's the worst case. Something has gone wrong. Now you have to figure out what it was. Someone sees that, they're immediately going to say git blame, hey, and they're going to get you on the IM and complain, yell at you. Okay. All right. So a little bit of formalish language. So restrictions on them across multiple declarations. So given a function f, for each parameter in that function f, there will be only a single declaration that provides a default argument. Okay? So you can't say there's a default argument for parameter 2 here and another default argument for parameter 2 later on. A parameter p that has a default argument in a declaration for function f is allowed only if there are visible default arguments for all following parameters of function f. Visible is, that word visible is italicized for a reason that I'll get to in a minute. For function f called within a scope s, the effective DFAs for f are the union of all visible DFAs at the call site. Okay? So whenever you make the call and you say, oh, I need to get the default argument, he looks at all of the declarations for that function and he makes a union of all the default arguments that were visible, and that's what he uses. But there's this big blank here, right? I wonder what that's about. So this is weird. The first declaration in a scope hides any of the previously provided default arguments for that function. This is very counterintuitive because we think, well, you're declaring this, it should add, even though you're in a just because you're in a nested scope doesn't mean you should throw away everything you knew. So now there's an extra third bullet point. Within scope S, the first declaration for function f hides any previous visible default function arguments for function f within scope S. It's only active within that scope. There's an example that will clarify this in just a second. Probably terrify you too. So, okay. I'll let you look at this for just a second. Okay. Line 1. We have a function. Takes two parameters, a string and a bool. They both have defaults. It does the same thing that the previous slide did. So in main, we can assert, we call function, and yep, it's foo. That's what we expect. But we're going to enter a new scope block in lines 10 through 14. Okay, so we're now in a nested scope. We declare that function again, but this time we don't give it any default arguments on the declaration. Whenever we do that within this scope, those previous default arguments that were visible, they're not there anymore, right? So now if I try to call function with no parameters, the compiler's going to go, I don't know what you're talking about. I see a function that takes a string and a bool. You need to give me more stuff. I can't even just provide one, right? It's not like it hides some of them. It hides all of them. Okay, so then we have another scope block, 16 through 22. This one I provide two declarations, and I sort of give it new defaults, right? So now I'm going to say the new defaults are going to be baz and false, and I do it in two different declarations. Now I can call function with no parameters, but now since the second parameter is false, it's going to return an empty string. It doesn't care what the first parameter was, right? If I on line 17, if I had said bool equal true, then it would have returned baz, right? So, just the fact of redeclaring a function, because yeah, I'm good. I'm declaring just the function I need out of this header file. I'm being a good citizen. You could lose the ability to call with default arguments. Okay. Of course, it gets more complicated too. So using declarations, that's a way to pull names into a scope, right? It can cause more surprises. There are actually core issues in the standard committee for some of these things. So namespace n has a function that just concats two strings together. The second string is defaulted of bar. Okay. So then I say using n:(fn), right? So at that point, the function n:(fn) is available in the global namespace just by the name fn. Okay? The thing to know there is that the using declaration only pulls into the scope you're in the functions, the signatures that are like the overloads that are visible at that point. Okay? So if we declare more fn's somewhere, they're not going to be available in the global namespace. Okay? But whenever we evaluate the default arguments, he still looks at all of the visible default arguments for that function. So namespace n on line 9, right? Because of the using declaration, the declaration on line 11, which is equivalent to the one on line 2, because same name, same return type, same parameter types, sort of adds into the visible DFAs, right? So now that function has, two default arguments, foo and bar. But then we declare some overloads, some actual real, honest-to-God overloads of this thing, including one that takes no parameters, right? I'm taking no parameters. And I have another version of it that can also take no parameters because of the default arguments. So now, we're in our main function. I call in the middle just to verify, yep. If I call it normally, without at that point, then yep, we're good. But now, on line 19, when I call fn with no parameters, it's not going to see the fn that's on line 13 that takes no parameters, which is probably the one you would expect it to find. Instead, it's going to find the other declaration that's on line 2 and 11, and it's going to call that one instead, because only that overload was made visible by the using declaration on line 5. You would not expect this behavior. Anyone that says, oh yeah, I intended to do that, like they're lying, right? So another thing to think here is like, okay, well, say a using declaration is one of those common things, right? You're like, oh yeah, use a using declaration instead of a using directive, which pulls a whole namespace in. Right? You want to be good. You don't want to pull everything into your scope. Using directive doesn't have this problem, right? So you can end up somewhere in a header file you include does a using declaration somewhere. All of a sudden, you've got weird behavior you weren't expecting. Okay. It just keeps getting worse. So, honestly, that's probably the worst example, right? That's the one that's just like, what are you talking about? So let's move on to sort of like member functions of classes. So default arguments on base member functions are visible in your type, right? So, base has one of these things. Derived is derived from base. When I call, I make it derived D. When I call its member function fn, he's going to go, okay, fn. I need to find an fn. He's going to look in derived. He's going to, nope, there's no fn there. He's going to look in base and go, okay, fn is in the base. I can do that. And he's going to go, oh, you didn't give me any parameters or didn't give me any arguments. Okay, well, that's okay. I can invoke this with that default argument. And it works as you would expect. There's this other bit of peculiarity that I've put here for the purpose of illustration for later slides, but line 12, who's familiar with that syntax? Yeah, it's an unusual thing. You can always, as long as the accessibility of the thing up in the base is accessible to you, you can always like, no, really, give me the thing in the base, right? By using that syntax. Okay, so I said they're visible, right? That is unless you hide them with your own member function declarations. So in this case, it's basically the same thing, but now derived has his own fn, right? That's a different signature. It's a different function, right? Now, whenever I call dfn, it's going to look in derive for an fn, and it's going to go, I found one. Okay, let's put the parameters in. Okay, you didn't give me any arguments, but he expects one. Sorry, I give up. You didn't give me enough arguments. It won't compile. Okay, you can still use the base trick to call through to the base and get that basis function and call that one with no arguments. That's good. And line 18, like this has nothing to do with default arguments, but this is something that is disturbing, right? So if I saw this, I called D's fn with a string. Okay, well, D's fn takes a bool, not a string, right? I would hope maybe it would not compile, right? And if it did compile, I would think, okay, fine, you compiled. You're going to call the base one that has a string, right? Nope. Instead, there's an implicit conversion from string literal to bool. This is what lets you say standard string s equal false, and vice versa. So, yeah, it's not related, but it's a terrible thing. And you would get really confused if you had this situation going and you had to debug that. Okay, that's fine. But you can actually unhide them now with using declarations in your classes. Okay. So this time we're going to have two derived types. Okay. D1 is basically equivalent to what we had seen derived in the previous slide. You've got an overload, so now that hides the one in the base. But you say, I really want the ones that are the overloads that are in the base. I want those available here to me too. So you say using base fn. Great. Now I can use those. For the second derived type, I'm going to say using base fn first. That's going to pull all the ones from base in. But then I'm going to say auto fn string s equal bar. Now when I do that, that declaration now hides the one that was in the base because it's the same signature, right? So the using declaration is really saying, yeah, bring all those things in, unless I say that I'm going to have my own version of that exact function with its own, that exact signature. Okay, so base B, I call the function, I get foo. That's what I would expect. D, so I get D1, I call its function, I expect it to call the basis function, right, with its argument, so I get foo. D2, so I call the function with no arguments. It picks D2's copy of fn, which has a default argument of bar, and it adds some bangs to it, right? So I get bar, bang, bang, bang. But remember that trick. I can always get back to the bases function, right, by using the little base, the call through the base trick, right? And I can get foo there.
In your two derived, you change the ordering of the using declaration of the function. Does that matter?
I don't think so, but I would want to experiment. But the fact that it is in different order makes me think that I probably did it the other way, and there may have been a problem with it. And so it was a while ago when I wrote it. Okay. So default function members on overridden virtual member functions. So virtual member they're functions just like anybody else. So why not? We can do that, right? Well, it turns out there are yet more problems doing it this way. And this is actually a more well-known problem. So now my function here is a virtual, and I'm going to override it. All right? So string s equals foo, but my override doesn't provide a default argument, right? So now when I call the function from my base, from a base type, I get what I expect, foo, you returned s, right? But if I try to call it with no arguments from my derived, I get what we had seen before, right? Derives fn doesn't have, you can't call it with no parameters, right? So that doesn't compile. Okay, well, how do we make it compile? Yeah, what can we do about this? Let's see what the time is. Okay. So you can use what's called the non-virtual interface technique or method. At some points in time, it's been called the template method pattern. I think maybe some of Herb's early stuff with GotW called it that. But the basic idea is that the interface that consumers of this are going to use is not a virtual, right? It's a member of the base, no, not virtual. And instead it delegates to a private virtual function that you can override in any derived types, right? So now, when we use this pattern, we just say, okay, no, really call do_fn, which is virtual. It'll do dynamic dispatch. And then we'll get the right implementation of the function, right? And so now when I call d.fn, he goes, dfn. Okay, is there an fn inside derived? Nope, there's not. Okay, look in the base. He finds it, right? And he says, oh, there's a default argument there. I can actually do this call. And he gives you foo, but with the implementation of bang, bang, bang. Add bang, bang, bang to the end of it. Oh, great, perfect. That works. This is what we wanted, right? Oh, but what happens if we actually do want a default argument for that overriding function, right? I mean, it's reasonable. You might want to do this. So we do that, right? So now the derived has a default argument of bar, right? So maybe if you're calling it from derived with no argument, you would expect bar bang bang bang, right? And that's what you get. Base B, right? You call d.fn, and you get bar bang bang bang. But if you invoke this from the base, so you can get a reference to the base from that D object, right? If you call it from that static type, you're going to get base's default argument and derives implementation. Okay? It may be that you want to do that. Maybe, right? But, if I'm looking at either one of these function definitions just alone, keep in mind, this is a contrived example. Most of the time, these things are going to be separated by different files and, hundreds and hundreds of lines of code, right? You're not going to be able to see them together in the same context. So if I'm looking at either function alone, you're like, how did I get foo bang, bang, bang? I mean, it says bar bang, bang, bang. I should concatenate those, right? So that's a problem. Right? So how might we fix that? I want bar bang, bang, bang for that last one. Right? And what can we do? Well, the problem is that the default arguments are determined from the static type, whereas the implementation that gets picked is because of dynamic dispatch, right? You dynamically figure out which implementation to use. So if you want the default argument to also be dynamically determined, well, guess what? You have to call a virtual function for the default argument, right? So, and in this particular case, we've just said we're going to make it delegated as well instead of using default arguments. In fact, you have to do that because if you put the, is that right? Yeah, I think you have to do that. Because if you provided the default argument, if you called this this virtual method as a part of the default argument, your type is still your base, right? So he's going to get the wrong one. So you have to use delegation to fix this. Now, this is a lot more code to make that work. And now imagine if you had multiple parameters with defaults provided. This would get out of hand very, very quickly, right? Okay, we're doing good on time. Okay, yeah, so, I mean, is that better? I don't know. Probably not. It's much more complicated. So take it for what it is. All right, so far we've avoided talking about templates, right? So now we're gonna talk some about templates. So default arguments for function templates add some extra complexity. There's a section in the standard about templates that talks specifically about this, and there are certain rules, and they give it a name: default argument instantiation. Okay, so that's the thing we're going to talk about right now. So this is a summary. You can find the actual paragraph in the standard up there. For a function template, and presumably a member function of any class templates, default arguments are not always completely parsed until the template has been called in a way that requires the default argument. Right? So it may not parse the full expression completely until you've instantiated the template and have required the default argument. I mean, you've called that function template with no arguments, or you have to substitute them in, right? So this sounds an awful lot like two-phase lookup problems, right? Okay, so we've got a template on lines 1, 2, and 3, a function template. Its default argument is a get function that takes t. So that's a dependent expression, right? It depends on the type, the value of the template parameter, right? So that means whenever the compiler parses this, he can't actually make a final determination of whether or not that's valid without knowing what the type is. That's what it means to be dependent, okay? So, he just returns whatever it was. So later on, we have a class A, we have a function called get, finally, called return, it just returns 42. So now on line 11, we instantiate that function template with type A. So then we go, okay, we got a type A. In theory, we could now verify that get function is valid, right? But it doesn't necessarily do it until we actually invoke that parameter and we need it, right? So that works. Now, if I called fn of a with like an actual integer, presumably it doesn't have to worry about whether get is valid or not. It could still be a bad substitution. Okay. So we talked about that was a dependent type, in a dependent expression. What if it's not dependent? So this time, I'm going to do weird stuff, right? I'm going to say, cast the integer 42 to bool, right? Something nonsensical, right? And then assign that to an integer. Sure, why not? So the key here is that cast to bool is using C++ 11's uniform initialization syntax. That prevents narrowing conversions, right? So if I just said inside like main int n equal bool 40, curly 42, the compiler would go, nope, not going to let you do that, right? But now remember, that's not a dependent expression, right? So the compiler should be able to like fully parse that and determine that it's a bad thing when it sees the template declaration, right? Well, so I did some experiments on this. MSVC and Clang say, yeah, no, we're not going to let you do that. But GCC's like, yeah, sure, bring it on, I mean, chances of you using this thing are pretty small, I guess we'll just keep going. So if I even, on line 9, I've instantiated the template now, but I've not used the default argument. Okay, again, GCC has an opportunity to go, hey, there's a default argument that's not good, right? But he doesn't. He's just like, yeah, sure, why not? Let's do it. It's only when you actually instantiate the template and call it such it needs the default argument that it says, no, bool 40, no, can't do that. That's not good. So I asked the core language group in the committee, is this ill-formed? Like, what's the story here? They have different, diverging implementations here. And the story, the answer that came back was that it's ill-formed. This is ill-formed. Line 2 is ill-formed, but it's no diagnostic required. You could argue like, okay, no diagnostic required. Should it work? Like, should it like actually build and run and like do nominally what you might expect if you don't invoke it that way? I guess it's a theoretical question, right? Okay, there's one other variant of this. So what if the default argument is dependent, but it's actually invalid once you determine the dependent, like you substitute a type in, and now it's invalid, right? So this time, I'm actually doing this cast with the type that was given to me, right? On line 2, right? So if I give it an int, it should be like, sure, peachy, good there. If I give it a bool, like was in the previous example, what's going to happen, right? So, yeah, when they declare, when just the declaration, all of them are like, yeah, sure, that's sure, that can work. Then on line 9, I instantiate the template, but I don't use the default argument. Okay, they're all still like, yeah, let's do it. It makes sense, right? You didn't use this in an invalid way. It's only whenever you invoke it, you instantiate it, and need the default argument that they're all finally like, yeah, that's what. And for what it's worth, this is good. Like, this is the behavior I would expect, right? Yay! It actually did what I thought it was going to do. Okay, so all those examples of everything that can go wrong, I'll repeat myself from the beginning. Don't do these things. Just ignore it. Just don't use default arguments, right? So then if you take that advice, well, what are you going to do about it, right? Like how, what do we do? Okay, well, you got some options. You can have coding guidelines, like, yeah, don't use these things, right? Who has coding guidelines in your industry? Okay, you should have them if you don't, right? They're important. You can use code review, right? You get a senior engineer to look at every junior engineer's code, make sure they're not doing this. You could use static analysis tools. Static analysis tools, for most of these things, static analysis tools can detect, or it can certainly detect, hey, you provided a default argument in this signature, don't do that, right? That might be overkill, right? But if your rules for your industry or your profession say don't do that, then it could conceivably do that. And then unit testing, right? This way you can avoid weird, unexpected behavior. Okay, so it's 9:46. We have about 14 minutes left. I don't want to go over time because there's no more talks. There's another talk right after this. I can take questions. The more questions I take, the less of the really cool stuff we'll get to see, though. So, anybody if you have a question, just go up to the mic, or it's a small room. You can yell it, and I'll repeat it what it is. Everybody wants to see the cool stuff. Okay. Okay, so I said, this caveat, like, oh, but maybe the cool stuff, maybe we should use it for these things. I'm still not convinced. I haven't convinced myself that these are worth it, but they are pretty neat. Okay, so who knows about the library TS? Did you have a question? No. Okay, so the library TS. The library fundamentals TS. So there's version 1, there's version 2, presumably there'll be version 3. So this is a type that's added to the version 2 of the library fundamentals TS. Just from the name, does anybody want to guess what it's supposed to do? Nobody. Yeah. File and line number, right? It gives you that information. But you say, but we already have that with the file and line macros, right? Well, this gives us an actual full type with functions and things. We can pass it around as a unit and things like that. As far as I know, there are no existing full implementations of this in any of the shipping libraries, standard libraries. So this code, of all of the other code, I should say, all of the other code is available at this sort of relative path to the GitHub link that I posted on the first slide. If you need that later, you can find me and I'll give it to you. This is the one that doesn't actually compile yet, right? So with this, you could say something like, I'm going to define my own custom assertion function, right? And this uses the trick that the default argument is evaluated in the context of where the function is called and it needs it, right? So the usage of it on line 24, you say, my assert false, I did this on purpose, right? Whenever you call that, the source location argument that's going to get passed in is loc current. Okay, that's evaluated in the context of this file, line 24. Right? So the column number and line and function name are all going to be relative to the main function on line 24. So you're going to get that information about, oh yeah, I asserted on this in this file on this line, it was this column number, right? So, does anybody here worked on like unit testing frameworks or things like that have assertion macros? Yeah. So That's really the big motivation for this, is to eliminate those macros, right? You can have real, honest-to-God functions that do your assertions, right? We'll see if people actually start using this once it gets implemented in a library, in a shipping library. Okay. So some people earlier said that they attended the Context for All the Things talk yesterday. Can I get hands again who all attended that? Okay, a few more people trickled in afterwards. So they talked some about a problem, right, that was really, really prevalent when C++11 first shipped. That if you have a function that's marked as const_expr, there's no guarantee that it will be actually evaluated at compile time. But there were restrictions on the things that you could put in there. And that led to a lot of recursive functions, right? That was the only way to do it in C++11 for const_expr functions. But if that function got called at runtime, it may not be the ideal implementation for that function, right? It may be costly to have all that recursion. C++14 made it a little easier. You can use more general programming structures in a const_expr function. But there's still this problem of, I'm in a const_expr function, and I want to write code that is cognizant of the fact that it's being called in a const_expr context, right? And they explicitly called this out as a problem in the presentation. There are some standard proposals to make that more a part of the language, so you could tie into that. Otherwise, you have to do Sphene tricks and other stuff to do it. So here's an implementation that uses default function arguments. It's a hack, I'll admit it. But again, it uses the fact that something is evaluated at the call site, which is where the context is about we're being called in a constant expression, right? So focus real quick on lines 12 through 19. Okay? So I can call function or fn with a parameter of 4, and I can't put that in a static assert because function with 4, let's see. Oh yeah, I'll get that. But that's a runtime behavior. So I can do a runtime assert, right? That's the right behavior. The way I've structured this is you can actually explicitly say, no. Give me the compile time behavior, please. So if you want the compile time behavior and you're in a const_expr context, you can just say, no, tag compile time, right? So now let's look at the implementation of fn. So it's a const_expr function, and it takes a second argument, which is a tag. The default argument there is this function called runtime. Runtime, if you look at that, is a function that is not const_expr, right? So it can only be evaluated at runtime, which means if I call fn with only one parameter, the second parameter can only be used at runtime, right? So that's why line 14 fails to compile. He's like, nope, you called runtime, which can't be used here, right? The other thing to note about it is that in a const_expr function, you can write code that is not const_expr. You can't call it, you can't evaluate it in a const_expr context, but you can write it. As long as it doesn't get evaluated whenever you're doing the const_expr stuff, then it's fine, right? So I have identity, which is another runtime function. And so I say, if you have been told this is runtime behavior, just call the runtime thing. Otherwise, do the compile time thing, right? So in this, what we're doing here really is, instead of magically determining the context of where we're being evaluated, we're explicitly passing that in, right? I want the compile time behavior, please, right? So it's not quite the same, but you can emulate this, and you can get different algorithms, based on whether or not you're runtime or compile time. You just have to be a little bit more explicit about, hey, I'm in compile time. Okay, we've got 6 minutes. Okay, so virtual dispatch. Sometimes you might want to say, yeah, this is the right function, but I really want to know who it was, like what type it was that was the source of the call that dispatched to me, right? This is terrible, but there are reasons you could conceivably do this. It's a little bit small text because it's more lines. But the idea is that all of the types that you know about, you can provide a static const per value, an ID, make them unique, right? And you can provide like a name, you know. It depends on what you're actually trying to implement, what you would provide there. And so what I'm doing here in my so the base is pure virtual. There's no implementation there, right? But in my implemented override, I'm looking up the name for the ID that I was originally called with. And the trick here is that, remember, the default argument is evaluated based on what the static type was that made the call, right? So it gets the ID of that type, right? And since I've registered these things up with some map or something, I can now look up to see, oh, it was that type, right? So yeah, this works. So if I create a derived D and I call fn, he print, you know, it's derived, right? Yeah, derived was the type that called this. But if I get a reference to the base, right, and I call the fn from that object, from that reference, I get base, because he says, oh yeah, the default argument was determined by the base, by the static type, and then I can look that up in the implementation. Okay? There are all sorts of terrible, terrible things you could do with this trick. This is probably the one that I'm the least certain, like, if this is a good or a bad thing. I was thinking last night, there are ways you could use this to solve the virtual problem when you have multiple defaults. You might be able to actually hook in and say, no, here's all the defaults for the different types that might call this thing. Crazy stuff. Okay, we got 4 minutes. Nominally, that's the end of the presentation. Now, I did say that if we went fast, I could do a demo. So, questions or a real quick demo? Demo. Okay, let's see if it works. Doing live demos are terrible, but... Okay, so you remember that compile time versus runtime example, right? So you might think, well, okay, what would I use that for? Right? Great, you can do that. So I came up with an idea to use it to provide sort of mock values, right? So it is mock. Okay. So I'm going to have a class. This is my tag, class mock. That's my tag, compile time, runtime, right? I've got my runtime function that says, no, don't do mocking. It just returns that. Now I've got this type, file data. And he's gonna keep this mock state thing as a member. And he's going to take that in as an argument on his constructor, right? And the default is going to be no mock. Now, give me the real runtime behavior for this thing normally, right? And he stores it away. So then I've got a const per function that says, hey, give me some numbers, right? And just say, normally what it would do is it goes and reads from a file. You know, something runtime requires runtime behavior, right? But if I've said, no, I want mocked values, please. Don't go do that runtime stuff. You could implement your mock behavior right there, right? And then else, you know, I'm going to go delegate a read, and read is going to go to a file and go do the reading, right? So there's delegate read, you know. So it just goes and reads in from this file these numbers and puts them in the array, and then there you go. Okay, so the first block, 46 through 52, I instantiate my file data with no parameters. So I'm expressly selecting the runtime real behavior, right? I say get numbers, and I get those numbers. For 54 through 60, I say no, give me the mock behavior. And then, you know, it's the same function call, but I get different numbers and I can static assert them, right? Because my numbers thing is a const expert. So who thinks this is just going to work, or who thinks this, you know, just not really going to work? I wouldn't show it if it wasn't going to work, right? Session is over. All right. I'm going to show that I got 1 minute from my clock. So I have this little script that compiles and runs things. What did I do wrong? Oh, I didn't give it a name. So it compiles it, it runs it, and all the assertions pass. Right. So that's the end of my session. If you want to ask me questions about anything, I would say congregate over there. We can do it sort of offline. And thanks for attending my session. Have fun at the next keynote.